Let greatest integer of x denote the greatest integer not exceeding x. That is, if you think about it, of 1.2 is 1, 3.79 is 3, greatest integer of minus 1.83 is minus 2. If it were an integer, greatest integer of 3 is 3. Right, lovely. And I'm going to call this curve bracket of x is x minus greatest integer of x. Curve bracket of 2.79 is 2.79 minus greatest integer of 2.79, which is 0.79. Lovely. So, for want of a better word, I'm going to call it the decimal part of x. And so, it works beautifully if you're talking about positive x. Negative x, it will not be the decimal part, it will be the remaining. Right? But hey, I need a phrase, so I'm going to call it the decimal part of x. If n is a natural number, then the sum of all values of x satisfying the equation 2 into greatest integer of x, 2 into greatest integer of x equals x plus n times decimal part of x. I don't even know how to approach this question. When n is a natural number, the sum of all values of x satisfying the equation blah 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 is what is that equal to. And what I'm going to do, I have choices. I'm going to play with this a little bit. I know that x is nothing but greatest integer of x plus decimal part of x, the remaining part of x. So what I'm going to do, I'm going to say, hey, this I'm going to write it as greatest integer of x plus greatest integer of x, and then add the decimal part of x equal to x plus n times greatest integer of x plus, n times decimal part of x plus decimal part of x. What am I doing? I'm adding decimal part of x to both sides. Why am I doing that? Because here I can identify an x here and an x here. These two disappear. Or we simply have a situation where we have greatest integer of x equals n plus 1 times decimal part of x. Lovely, brilliant. Now we need to find sum of all values of x satisfying the equation, this equation. For a given n, I don't know how to do this. I'm going to put an n. I'm going to say, hey, n equal to 1. Decimal part of x, greatest integer of x is 2 times decimal part of x. Decimal part of x goes from 0 to 0.999999. So 2 times decimal part of x can go from 0 to little less than 2. Right? So it can go from 0 to 2, but less than 2. It cannot be 2. When will it be 0? When this is 0, then this should also be 0. Then 0 is a solution. Then hey, I don't care about 0 because 0 is a possible solution for this equation. Let's keep that aside. Let's not worry about 0. 0 is always a solution for this equation. Greatest integer of 0 is 0, x is 0, decimal part of 0 is 0. It goes to 0 comfortably. So if you ignore 0, then 2 times decimal part of x is equal to greatest integer of x. The only place this can happen is if I have this going to 1 and that going to 1 as well. Right? Or I could have a scenario where this is 2 into 0.5 equal to 1. When will that happen? When x is 1.5. Greatest integer should be 1. The decimal part should be 1. When x is 1.5 and n is 2. And so then we can say greatest integer of x is 1. Decimal part of x is 0.5. 0.5 into 2 is 1. So when n is 1, we have one solution, x equal to 1.5. I'm going to stop with that. I'm going to say, hey, nice. You set the ball rolling on this. Let's grab on and put n equal to 4. 2 into greatest integer of x equals, so you've simplified this, greatest integer of x equals 5 times decimal part of x. 5 times decimal part of x cannot be 5. That should be less than 5. 0, 1, 2, 3, 4. If we ignored 0, We're only thinking about 1, 2, 3, 4. So this can be 1, this can be 2, this can be 3, this can be 4. Nice, brilliant. So what will be the decimal part of x? This is the greatest integer part of x. This were 1. Then 5 into decimal part of x should be this. That means decimal part of x should be 1 by 5. This is 2. Decimal part of x should be 2 by 5. 3 by 5. 4 by 5. Brilliant. Now we are on to something. Now we don't need to find how many values are there. We don't need to find the different solutions. We want to find the sum of all such possible values of x. And so 1, 1 by 5, 2, 2 by 5, 3, 3 by 5, 4, 4 by 5. Add all of that up. So this is 1 plus 2 plus 3 plus 4, 10 plus 10 by 5. Nice, brilliant. Because it is 1 plus 2 plus 3 plus 4 by 5. 1 plus 2 plus 3 plus 4 is 5. 10 plus 10 by 5 is 12. When n is equal to 4, our answer is equal to 12. Now we have to extrapolate this. And so when n becomes 5, this will become 6. I'll have 1, 2, 3, 4, 5. I'll have 1, 1 by 6, 2, 2 by 6, 3, 3 by 6, 4, 4 by 6, 5, 5 by 6. Now I'm going to solve it for n and not for numbers. N is n. Greatest integer of x equals n plus 1 times decimal part of x. This is 1. This is, I'm just thinking, I'm just pausing to see what it should be. It should be 1 by n plus 1, n plus 1, 2, 2 by n plus 1, 3, 3 by n plus 1, all the way till n. This is n by n plus 1. If I add all of this, n into n plus 1 by 2. So n into n plus 1 by 2. 1 by n plus 1 plus 2 plus 3 plus 3 is n into n plus 1 by 2. Times n plus 1. So this goes away. N by 2 into n plus 1 plus 1. N into n plus 2 by 2. This answer. Absolutely delightful question. It took me a long way to just get the hang of this question. Think about greatest integer of x, decimal part of x, understand that, and think about what solutions are possible if n were 1, then n equal to 3, 4, then n equal to n. Solve it methodically, get to the answer. Probably not a very meaningful question to attack in an exam context, but a fun question to attack just like that. And so I'm doing it just like that, so I'm quite enjoying it. But from an exam point of view, probably a question, look at it and go, very interesting. Thank you very much. I'll come back to it later.